Hi, Assalamualaikum warahmatullahi wabarakatuh. My name is Shahira Sofea binti Marzuki, metric number S59486. Today, I will be discussing about a metal complex. I have chosen PT-NH32Cl2, which is cis-platin with the structure shown, and the oxidation number of the metal ion, which is platinum, is 2+. The calculation is as shown. Next, the ligand are 2 ammonia and 2 chloride ion ligands. The complex name is cis-platin or cis-diamine dichloroplatinum 2. It is called cis-diamine dichloroplatinum 2 because cis, pairs of NH3 and Cl2 are on the same side. Diamine because of 2 NH3, dichloro because of 2 Cl. The metal ion is platinum, and 2, which is the oxidation number of metal ion. Next, we move on to synthesis of cis-platin. The precursor K2-PtCl4 is merged with a saturated solution of Ki, and the result is K2-PtCl4 and KCl. For the chemical reaction to be completed, a disproportionately high amount of Ki as a weakened nucleophile is merged to this, is added to NH3 equivalent, and the mixture becomes cis PtI2 NH32 because of the trans effect. The reaction takes place quantitatively because ammonia is a much stronger nucleophile than iodide. Cis-PtI2NH32 is a yellow solid state substance which is filtered, dried and mixed with an aqueous silver nitrate solution. This forms soluble cis-PtO2OH2 NH32 2+, and insoluble silver iodide which precipitates and therefore also causes this reaction to proceed quantitatively because silver iodide is continuously removed from thermodynamic equilibrium constant. The silver iodide is filtered off and the solution is mixed with potassium chloride, which leads to the product cis-platin as a yellow powder which precipitates and can be filtered off. The synthesis scheme of cis-platin is as shown in the diagram. Kirchhoff method is also used to synthesize cis-platin. The Kirchhoff method provides a way to check the samples of their cis and trans platinum content, and is used to quantify the trans platinum impurities in clinical cis-platin. It uses thiourea. The process is as shown. With thiourea added to a sample of cis-platin, the result is a deep yellow solution of PtTH4Cl2, while added to transplatin, it reacts to the white insoluble PT-NH32 TH2Cl2. The method is based on the stronger trans effect of thiourea compared to chloride. So the next question is to list all term symbols by constructing microstate table. The term symbol is D8, so we calculate this by using multiplicity. The formula for multiplicity is 2s plus 1, so it's 2 times 1 equals to 2, and 2 plus 1, which is 3. And to obtain J, we use formula L plus S, which is 3 plus 1, and we get 4. Finally, we get 3F4. So next is microstate table. For D8, I refer to D2 microstate table because they are the same. The total number of microstates for D8 is 45, and the calculation is shown in the slide. I have also listed down all the microstates in the microstate table in the next slide. So for UVV spectra of cis-platin, the GC3 and 4 shows lambda max as 4 to 9 nanometer in the UVV region, whereas GC3 and 4 cis-platin complex shows lambda maximum at 419 nanometer. It is blue shifted by 10 nanometer in solvent phase. According to the experimental UV visible spectrum, cis-platin drug shows maximum absorption at 207 nanometer, and the GC3 and 4 shows maximum absorption between 200 and 450 nanometer. By comparing the experimental and theoretical spectra, it was found that theoretical UVV spectra of cis-platin drug in both gases, lambda max equals to 259 nanometer, and this aqueous phase, lambda max 222 nanometer, are in close agreement to experimental absorption spectrum, which is lambda max is 207 nanometer. There are a few applications of cis-platin. First is cancer chemotherapy. Cis-platin is used widely in the treatment of ovarian, bladder, and testicular malignancies, as well as squamous cell carcinomas. Cis-platin exerts its chemotherapeutic effects by cross-linking DNA, thereby disrupting cell division. The effect of cis-platin on tumor vasculature has also been implicated in its antineoplastic effect. In immune sensitization, cisplatin therapy induces an immune response that enhances clearance of HPV positive tumors. The in vivo experiment in immune incompetent mice showed that T and B lymphocytes were necessary for clearance of HPV positive tumors during chemotherapy. The role of the functional p53 protein. The National Cancer Institute discovered that a functional p53 protein is essential for a successful response to cisplatin treatment in A60 cell line. This cancer suppressor is important for a wide range of cellular processes and regulates the balance between cell cycle arrest and apoptotic cell death. Next, DNA repair mechanism. Nucleotide excision repair proteins are a multi-protein complex that is ATP dependent and capable of repairing both inter-strand and intra-strand DNA cisplatin adducts. In distinct human and rodent and ER systems, successful repair of 1,2 DGPG and 1,3 DGPNPG intra-strand crosslinks has been discovered. And this healing pathway can reverse injuries caused by chemotherapy medicines, UV radiation, and oxidative stress.